I am jumping to page 6 of the notes. Page 5 is an entire page dedicated to the rules for this process. I think that this is just something you need to watch and practice. And if you need to refer back to page 5 to remember any part of the process, then you may. I am just going to start working problems where I give you a system of equations and we use matrices to solve the system. So in example 5, let's go ahead and read the directions. Okay, so example 5 says, solve each system using Gauss-Jordan elimination. That is what this process is called. Okay, and then you need to indicate all row operations, like how you go from one matrix to the next. In sections 4.5 and 4.6, I tend to teach those sections together. You are going to learn a second matrix method to solve a system of equations, and so the directions will read differently. So what I need you to understand is that if you see this phrase Gauss-Jordan elimination, it is referring to the process that we are about to do. Okay, you've got to understand that. Gauss-Jordan elimination is the process we are about to do. Okay, so in example 5a, our system of equations is 3x minus 2y is equal to 14, and x plus 3y is equal to 1. Okay, so the first thing we're going to do is convert this system of equations into an augmented matrix. So remember, you're just writing down the numbers. The variables do not come into the matrix. All right, so our first matrix is going to be, for the first equation, I have a 3 in front of x, a negative 2 in front of y, draw the vertical line for the equal sign, and then there's a 14 on the right side. Okay, so that's the first equation put into the matrix. The second equation, okay, there is a 1 in front of x, a positive 3 in front of y, and a 1 on the right of the equal sign. Okay, so remember how your initial matrix is set up. The first column, those are numbers in front of x. The second column, those are numbers in front of y. And the column to the right of the vertical line is the numbers on the right side of the equal sign. Okay, all right, here it goes. Okay, we are going to operate on this matrix. Okay, we are going to use the 3 row operations that we discussed, okay, to produce a series of equivalent matrices. Okay, each matrix that we get will represent a system of equations that's equivalent to the original. Okay, it will have the same solution as the original. Okay, so this is how we do this. Like I said, we can only use the 3 row operations we talked about in the last example. Okay, that's it, nothing else. You can't invent your own row operations. Okay, the goal, okay, you've got to keep the goal in mind. The goal in doing all of these problems, including when we jump to the next section and we get to bigger systems, okay, your goal right now, okay, is to make this augmented matrix look like this, okay? 1, 0, 0, 1. That's what you want the left side of the vertical line to look like. And then on the right side is going to be some number and then another number, okay? They may not be the same, so that's why I used P and Q, okay? That is your goal. You want the left side to be 1, 0, 0, 1, okay? So 1's on the principal diagonal and 0's elsewhere to the left of the vertical line, okay? And then once you get that, you can stop and interpret the solution to the system, okay? That is what we're aiming for. It is a systematic process, okay? Basically, the way it works is it is going to run column by column. We will start with column number 1, okay? We will first obtain the 1 on the main diagonal or the principal diagonal. So we will secure the 1 in the first row, first column, okay, by using the row operations. Once we have the 1, we will zero out the rest of the column, Okay, so we will put this 0 here in position 2, 1. Okay, then once the first column is done, we will move on to the second column. Okay, you will first secure the 1 on the principal diagonal, okay, through the row operations. Okay, once you have the 1 here, you can use that 1 to 0 out the rest of the column. So you will put the 0 using the row operations. You will obtain a 0 in position 1, 2. Okay, and as you generate all these matrices, all the numbers in the matrices change. Okay, and then you'll finally, hopefully, end up with your goal matrix. And then these numbers will help you get the answer to the system. Okay, just a word of warning going into this. Okay, there may be times where you cannot obtain the goal on the left. Okay, where you can't get the 1, 0, 0, 1. And we will talk about what that means when we get there. Okay. All right, so this, for our first matrix, you want to transform the left side into this, okay? I'm going to go ahead and tell you this doesn't actually formally come up until section 4.5, I think. This 1, 0, 0, 1, where if you have a matrix and there's 1s on the main diagonal and there's 0s everywhere else, so like to the left of the vertical line, that's what I'm describing. 1s on the principal diagonal and then 0s elsewhere. That is called the identity matrix, okay? Your goal is to obtain the identity matrix to the left of the vertical line every time you do Gauss-Jordan elimination, okay? Sometimes it can't happen. We will talk about those situations. All right, so here we go. Back to our first initial augmented matrix, okay? Again, do this systematically, okay? Because you don't want to undo anything you've already done. That's why we have to follow this process, okay? We are going to start in the first column, okay? Your first thing that you've got to do in the first column is to secure a 1 on the main diagonal, okay? So here's your main diagonal elements, the 3 and the 3 and the 3, okay? You want to put a 1 on the principal diagonal, okay? So right now it's a 3. You need to change that to a 1, okay? The easiest thing you can do is switch the 2 rows, okay? If you switch rows 1 and 2, you will get the 1 in that position, okay? So I'm going to notate what I do, and I expect you to as well. I am going to switch row 1 and row 2, and that's going to give me a new matrix, okay? So here comes my next matrix. Okay, that's it, okay? So I have secured the 1 in the first row and first column, okay? All right, we are still working in the first column, okay? Now that I've got that 1 secured on the principal diagonal, I need to 0 out the rest of the column, okay? So this 3 needs to change to a 0, okay? So usually what you're going to do is you secure your 1 on your main diagonal, and then you use that 1 to 0 out the rest of the column, okay? And you're usually going to use row operation number 3, where you can replace a row with its sum or difference with a multiple of another row, okay? All right, so here's how it works, okay? So I want this to be 0, okay, but there is a 3 there. Well, what would cancel out a positive 3? Well, a negative 3, okay? So what I'm going to do is, remember, I want to change the second row, okay? So what I can do is add back to the second row a multiple of another row, okay? If I multiply row 1 by negative 3, that would put a negative 3 right here. And then I can add it back to positive 3, and then I will have my 0, okay? So I'm going to take row 1 and multiply it by negative 3, okay? I'm going to do negative 3 times the first row. That's going to put a negative 3 in this position. Add it back to the second row. Okay, so negative 3 plus 3, that will give me a 0 in this position. Okay? All right, so let's do that. This is going to be our row operation. Okay? And that is typically what you do. You use the third row operation to get the zeros. Okay? We are only changing row 2. Okay, so row 1 will stay put. Okay? And I usually write that in before changing the new row, just so there's no confusion. I know I'm not changing row 1, leave it alone. Go ahead and write it in, okay? All right, so I'm gonna do the workout to the side. I highly recommend that you do this, okay? Yes, you're just adding or subtracting numbers, but believe me, it's a lot of arithmetic. You can easily make a mistake, okay? Write it out, you're less likely to make a mistake, okay? I'm just gonna go out to the side. I'm gonna do -3 times row 1, okay? That is gonna give me -3, -9, -3. I'm going to add it back to the second row. Okay, this is the second row. Okay. And then let's see, that's going to give us your adding. Okay, so this is going to be -3 plus 3 is 0. -9 plus -2 is -11. And then -3 plus 14 is +11. Okay, that is now your new second row. Okay, and you can pop it in here. Okay, so that's what it looks like. Oops, that should be +11. Whoops, let me take that off. All right, so here is your new second row, okay? Again, this is how you do the process. You see a whole bunch of matrices being generated, and we're still not done, okay? But we are done with the first column. Look at the first column. You've got the 1 on the main diagonal, and you've zeroed out the rest of the column. So that means, hey, I'm free to move on to column 2 now, okay? You don't have to put the arrow here, but I usually write it there for your reference so you can see where we're working, okay? Now that we're in a new column, you're in column 2, the first thing you want to change is put the 1 on the main diagonal, okay? So -11 is the number on the principal or the main diagonal. So we need to change that guy to a 1, okay? So the easiest way to do that, okay, if you look at this row, okay, all of these numbers are divisible by 11, okay, or -11, okay. The easiest way to get a 1 right here is to divide by -11. -11 divided by -11 is 1, okay. So we're going to take this whole row and we're going to divide by -11, okay. So let's go ahead and do that. All right, so you can see this is going to create, you need a lot of room to do these problems. So I'm going to, I can't write it all in a straight line, so I'm going to draw a little road map about where I'm going from this point on. Let's see here. So from here, we will go over here. Okay, so we will go down this way. Okay. All right. Maybe I should number them. That might be a good idea too. Like this will be matrix 1, matrix 2. Maybe that'll be a little easier for you to follow if you're reading back through this. Okay, so I'll go ahead and put matrix 4 right here. Okay, so remember, to get this, we are going to do, the row operation is now going to be, let's see, row 2. We're going to divide row 2 by -11, okay, and that's going to become the new row 2, okay, because that is the second row operation where you are allowed to multiply or divide any row by a non-zero number, okay? All right, so in this case, we are not changing row 1, so row 1 will remain 1, 3, 1, okay? And then we will go ahead and take every number in row 2 and divide it by -11, okay? So remember, the row currently is 0, -11, 11, okay? I'm going to divide everything by -11, okay? So I will get 0, 1, -1, okay? So that will be my new second row, okay? All right, so there we go, okay? We are in our second column. We've gotten the 1 on the main diagonal, so that's great, okay? And so now that we've got the 1 there, we can go ahead and secure the 0. Okay, so we need to zero out the rest of the column. Okay, so again, you're going to use this 1 in order to do that. Okay, so again, to get your zeros, you need to use that third row operation. We want to change row 1. Okay, so we need to add row 1, the one we're trying to change, to a multiple of another row. Okay, so it's saying, what do I need to multiply row 2 by to zero this out? Well, This has a 3, so we need to multiply this row by the opposite, which is -3. So if I do -3 times row 2, that's going to put a -3 right here. And then if I add it back to +3, I will get a 0. Okay, so we're going to do -3 times row 2 plus row 1 will become the new row 1. Okay. All right. So again, in our next matrix, which is number 5, okay, the second row will not change. So I'm going to go ahead and just write it in. Okay. And then I'll go out to the side and I'm going to do -3 times row 2. Okay. Here's row 2. So 0, or here's row 2, whichever way you want to look at it, times 0, 1, -1. That's going to give you 0, -3, +3, if you distribute all that. Okay, and then add it back to the first row. The first row is 1, 3, 1. Okay, that's going to give you 1, 0, 4. Okay, and there you go. All right, so we have reached our goal. Okay, to the left of the vertical line, we have the identity matrix, the 1, 0, 0, 1. Okay, that means we can stop. Okay, this system, since we could accomplish our goal, the system does have a solution. Okay, all right, so to get this, okay, I'm going to come back up here, I guess. Okay, here, I'm out of room. I really should have put this on one page. We have, let's see here, we have 1, 0, 0, 1, 4, and -1. Okay, turn this back into a system of equations. Okay, let's think about what this means. Okay, this means, remember, these are the numbers in front of x. That first column, these are numbers in front of x. That second column, these are numbers in front of y. And then these guys are the numbers on the other side of the equal sign. So if I translated that first equation, it would be 1 times x plus 0 times y is equal to 4. Okay, and then the second one would be 0 times x plus 1 times y is equal to -1. Okay, and so then if you simplified these equations, okay, this first equation would tell me that x plus 0 equals 4. Okay, so that's going to tell me x equals 4. And then the second equation, if you simplify, that's going to be 0 plus y equals -1. Whoops. So there is your solution to the system. Okay. And this is not something you have to do every time where you translate it back into equations. Okay. You can just look at your matrix. Okay. Once you end up with the identity right here, okay, the top number is going to be the x value and the bottom number is going to be the y value. Okay. So that is the solution to the system. Okay. And I'll go ahead and write it next to the system. Okay. So x has to be +4. Y has to be -1. Okay. And again, with any system of equations, you can check yourself. Okay. Plug these variable assignments back into the original system to make sure you get a true statement.